Okay, so hello everybody. So I'm Adrien. I'm 34 years old. I'm from France, northern East France. I've been smithing since 15 years and smelting from 10 years ago when I hurt my arm. So I begin with a French guy from Britain, and I learned a lot of it. And I I didn't stop. I started to make symposium with a lot of European friends, and now I'm currently doing smelting maybe 10 times a year with European friends only for hobby. So today I choose to present you the first oven I did. It's the Vaquita. Vaquita, it's well known for his parameter that we know everything about Vaquita, his dimension, how many air inside, etc. So this experiment has been done on the Museum of Puy-Couriot in Saint-Étienne, in the center of France. And I choose to present you this experimentation and photos because my friend Emmanuel, that it's an archaeometallurgist, helped me to do this presentation, and it's very well done. So thanks to Emmanuel Dransart, you have the name under the photos. And Eve also. So first, building the oven. So you're going to see it's a quite simple oven, very, very simple oven. So it's 20 by 20 centimeters inside. It's a square shape. 40 by 40 if you measure the outside. You have only one tuyere that goes inside, so one bloom, and the bottom where the temperature is going to be very high and the lump is going to appear, you are going to create the iron. It's a round shape, so the gray clay that you see on the walls, his name in France is Brasque. It's a high temperature clay protection. Actually, we have two ways of doing it. First one by using our own clay, but it's quite risky because it's going to be very, very hot indeed on a vaquita because it's very small. So the temperature is going to be on one single point. So it's going to be really hot. And the other way to do it is to buy some. So you have in clay factories, you have very high resistance clay, and it's the same to do the protection. And also the nozzle, the tuyere that goes inside, it's the same way, it is the same clay. So the oven is 6 bricks by level, and it's composed. We're going to see it after here. So it's a 6 brick by level, and if you you count everything, it's about 21 level of bricks. So this makes 2 by 6, 12, so 120 bricks you need to make a vaquita. If you do your job well, you are not going to hurt the bricks. So it's a quite efficient furnace for the money also, because it's going to create small blooms of good quality. If your iron ore, it's good quality. We know the parameter. We are going to, so we can see some of the parameters here. So 28 degrees of inclination for the tuyere. This is very important. The tuyere has to be put something like 20 centimeters from the bottom, and you need, it depends on your ore, how much is rich, or the form of the ore, so the alchemy of the ore, but you need between 60 and 1 meter of reduction. So this is going to be less bricks need or a little bit more bricks. So actually we said that vaquita, we need between 100 and 150 bricks. The 50 bricks, it's -5 or +5 levels of bricks that we need to have a good average a number of centimeters of reduction. So if you make the conversion, how centimeters makes some minutes. So how many minutes you have to go through the process to have a good reduction. So we have a conversion that is very simple to understand. Each 5 minutes, vaquita needs to be loaded. So we have 3 types of load. If you have already done some furnaces, only for vaquita, you can put some small bits of old bloom inside. It's going to create the first center of the bloom, and everything is going to stick on better. And after, you can use two different calibers of iron ore. You can use 0.2, so this is very thin, it's some sand, or you can use a caliber 2 to 5 millimeters. This is okay if you get inside the furnace after 2 hours. So when the furnace is very hot, vaquita allows you to go to 5 millimeters of diameter for the iron ore, but not more. You cannot throw a rock inside. It's not going to. It's not enough hot. You don't have enough gas to get rid of a bigger rock. So here we started the reduction at 10. So remember it, and we get 5 preloads of 500 grams inside the furnace. So here was the caliber that I said to you. And when we load the furnace, you can see it's filled to the top with charcoal. So it's entirely filled of charcoal. We can wait maybe 3 or 4 loads to see how regular it's the reduction going. And each 5 minutes, we have to get down of 1 brick. So 5 minutes for 5 centimeters of bricks of the thickness of the brick makes 1 minute, 1 centimeter. So it's very simple to remember. And after, we can stop to load, and every time you have to put the iron ore on a single point at the opposite of the tuyere. So the tuyere, it's on one wall. The opposite of the square, it's here that you put the sand, the iron sand, you put it here. You don't have to make it like a powder, very homogeneous layer, just on one point. So this is the reaction that's happened inside the furnace. So we begin between 300 and 500 degrees. It's better that you have 500 degrees. This is one of my advice: be hot. Sometimes we have too much steam in the beginning of the process, and it's make some problems. So 500 degrees, you put on the top your iron ore, so it's 3 Fe2O3, and you're going to have monoxide that is going to get through the chimney until the top. So it's hot, and it has the capacity to reduce, so it's a reduced gas, and it's going to pick the oxygen from the iron ore. So we're going to have, until the bottom, one less, until we have Fe, so iron. And actually, we can also create in the bottom, sometimes it's allowed us to have some FeC, so we can add some carbon inside the bloom. Not much in that type of furnace because it's too small, but every one of us know the big brother of the vaquita, that is Tatara, and Tatara produce a very high carbon steel on the edge of the bloom, not the inside. It has also some low carbon inside, but it's very high, contains something like 1.4 carbon. So it's just incredible. So this is how we check all the times and what we see inside the tuyere. My advice is write a lot about your reduction process, because you are going to learn about it later. When you are going to ask me the question, I'm going to show you how many data I have in 10 years. And this is very precious. So this is how we draw on the dashboard, and we have everything that we have inside. So here we can read that we have put 15 kilos, we have 1.5 of residue, and 13.5 kilos of iron ore that has been roasted. And we have also the average of charcoal that we put inside the reaction. So we can compare each time what we have done. Here we are waiting for the reduction hand. So we don't load again the furnace, and it's getting down until something like 3-4 bricks up the tuyere. The reason it's iron ore goes through the charcoal, it's always go through. So you don't have to put more charcoal at the end of process. I don't know why some people do this. Maybe they are happy to do it, or it's a way to another way to do it. But it is not needed because the iron always is going to get through the layer of charcoal. It has much speed. Here on the right of the photo, you see the traditional Japanese bellow. And this is also one of my advice. You can perfectly do with an electrical bellow your reduction, but in my opinion, the oscillation, wind, no wind, wind, no wind, the small separation between wind and no wind, it's a very powerful heat time, and it's better for a very liquid slag. And if you have a quite complicated ore to have some liquid slag, the traditional bellow is going to be better. So it's 15 and a half, 3.5 in the afternoon. So we are opening. So you can see it's only a chimney of bricks. So you just have to take a tongue and unbuild your furnace. You can also build a door in the bottom, but it's not often. You can use it maybe 2 times, but it's better to rebuild it. It's very fast. So when I'm in exhibition, I always unbuild the furnace. So you get down. The interesting thing is you are going to be able to look at how the temperature has impact on your bricks on each layers, and you are going really to discover, like an archaeologist, what the temperature, what the residue has done inside the chimney until the bottom. So here on the central photo, you see that we just have a cage, walls of very resistant clay. We just get the bricks out of it, and the air is processing. The process is continuing, and we just have a small bucket of clay that is maintaining the bloom that we see in a very bright color in the center of the photo, and a bit of charcoal all around. So it's very funny to do this with public around, because they can see actually what they didn't be able to see during the day. Here you can see the process for a few minutes, because after we have to cut the air and we have to forge the bloom. Here we can see éponge de fer, the bloom, iron bloom. You can see that the bloom, it's a square shape, because it has a bit of the corners. The bloom, when the iron ore reduces, it needs some mineral parts. So all time you have a very melted wall, because the process needs silicium. So we get it out. One of my advice also, it's clean. All has to be clean when it's hot, because when it's going to be cooled down, it's going to be very hard to knock it out from the bloom. So if you keep it for a museum, okay, you can let it like this if your museum wants this. But if you want to forge it, clean all the outside with an iron stick before getting in the water. So we clean it, and you see it on the second photo here, it's only the bloom, and we get it in water. So here there's 2 techniques. Some people forge it down directly, and others get it cold, cut it maybe before, or just when it's a very small bloom like this one, 3.5 kilo, you just get it cold. So a lot of slag is going to explode in the water, and the structure of the bloom is going to be really better to forge after. But you can strike a few times on it if you want to make a square or a rectangle before you call it down. It's not going to be a problem. So here we see the loom, and directly for the public, we have brought a big grinder, and we have cut it in 2 pieces. So you see it's quite compact. It has just one hole here. The explanation, when you are going to run 10, 20, 30, 100 of furnaces, you're going to be able to understand what happened in the process inside the bloom. It's maybe too much air, so maybe we have changed the speed, and it has been burned. Conclude this experimentation. We have 1.5 kilos of residue from a later reduction, so it was already ferrous. 20.1 kilos of charcoal, so this makes 4 bags of 10 liters. 30.5 kilos of iron ore that has been roasted. Some partly reduced bits in the furnace. You cannot. It's happened, but it's not often. You never sticks everything on the bloom. A compact bloom of 3.5 kilos. So if we make the ratio, we didn't tap some slag, it was pure enough. But if you make the ratio, this makes 23.5%. It is a low average because it's an European ore. It's a ore that we found on an archaeological site, so it's not very a rich ore. But if you use something like magnetite or Canadian hematite or something else that's very industrial, so very rich ore, something like 90 or 95% pure, you're going to have a very high result, something like 50 or 55%. So it's make a bloom of 6 kilo for this experimentation. 6 kilo, you have enough to forge it down and make something very good with it. And it's a very short experimentation for 6 kilo. Just a short thanks to my apprentice that you see in the middle, that is a tall and young guy. Emmanuel Dransart, it's in the right of the photo, and I'm on the left. And thanks also to Yves, that was the operator of the bellow.
The first question is come from Steve Rook. Do you dig your own ore, or do you use ore for steel, for steel making, or a mixture of both?
It's a mix of it. I'm a little bit a dwarf, a tall dwarf, because I measure 1.88 centimeters meters. So I'm a tall dwarf, but I'm dwarf in my conviction. So I use a lot of different types of ore. I love to go on different types of region and discover what ancient people has digged out from the ground. So I used ore from around Europe. I have a big presentation table for mineralogy. And each time I use a different ore, I keep one small rock of it. So it's a funny collection to do. Industrial ore, it's the best if you want to produce for your steel, for making commercial knife or tools, axe, etc. Don't use traditional ore because you always have a low content. You have several types of problems. Sometimes you can, it's true, you can be near a super source of iron ore, like in Ferrum Noricum, like I hear that someone came from Austria. In Austria, you have 6 iron ores in your mountains, and the 6 of it are just the perfect ore. Noricum, the province of Noricum, your country, has been bought. So Romans come and just said, okay, how many? And they just bought the country, the whole country, killing nobody because of iron ore and the way that the people of a day was already doing some iron and some steel. It's a crazy story, but yeah, sometimes I use industrial ones if I really want to produce a lot of iron for a friend. For example, a knife maker, a friend of mine, invites me to do an oven with him, and I produce for him, I don't know, 40 kilos of iron. I'm not going to come burn some charcoal to give him 10 kilos. It's not very efficient. So here I use industrial ore. If I'm in demonstration or in a museum or in symposium, I prefer to use local ore because there is also a story behind it.
The next question from Redmi Note 9 Pro. Have you tried melting bog iron? I know at least Finland and Sweden melted bloom steel in ancient times.
Bog iron. So I use a lot of bog iron, French bog iron, Netherlands bog iron, Germany bog iron, Irish bog iron, and Italian bog iron also. So bog irons are currently good iron ores. They are sometimes poor, are sometimes very rich, like the Irish bog iron, but it's just a crazy iron ore. It's a good thing to use, but if I have an advice, you can cut it half also with a siderite, because siderite is going to get you a more stable process, because bog ore sometimes has some element inside that are not very friendly with the ingot when you are going to forge down your ingot, like the phosphor. So if you cut it half, it's going to give you a production, and siderite is going to be able to get rid of the phosphor inside the process, because you have a C, and what's prefer the phosphor is the carbon. So you have to produce a pure iron, a pure phosphorus iron, and it's going to be okay for getting the ingot weld together, the different layers. And after you can combine it with a steel that you have produced with another iron ore. So often bog iron, they have sulfur and phosphor. So be careful. If you can make an analysis, put 300 euros on it and make the analysis, so you know what you have in between your hands. And sometimes you are very lucky, like Irish guys, and in Ireland there is no phosphor inside, and a crazy range of I think it's 82% of FeO free inside, so it's very, very high. So it depends on where you live.
The next question, which comes from Lars: is this setup able to recycle small offcuts and waste iron?
Yes. So this is a grappage furnace. What you want to know, it's the same shape than the vaquita, but it's the half tall. So it's 60 centimeters high and not 1.2. It's a very short furnace. Here, I advise you to use an electrical bellow, and you just put everything at the maximum that you can, and you burn everything. And you do this V shape in the bottom of the furnace with the trier in the center. So you do a V shape, and you are going to melt down. You're not going to really melt it down, but you are going to have a very molten piece of iron or a piece of bloom if you are recycling some bloom. And it's a very efficient method to do another ingot and to create some patterns. So if you can mix, for example, chain mails, nails, I don't know, bits of iron that you cut from your bars, etc. And the dimension of the oven, if you want to use the bottom of a vaquita, you cannot get more than 80 grams each time. If you get up, you are going to have some problems, because the oven is not enough, creating enough temperature to melt down more than 80 grams. I think maybe you can read from Lee Sauder. He has written a paper, I think, on it, and he has done a calculation on the dimension of the chamber and how many metal you can put inside. If I'm right, I think it's Lee that has written this down.
We can go to the next question, which comes from Steve Rook, and it is again, how do you roast the ore at what temperature?
A very good question. You take some rocks, the dimension of your fist, not less, not more. Okay, so you break the bigger pieces. the size of a fist. If you have smaller ones, you put it together. And usually I use a bucket. So it's a bucket. It's a round bucket, maybe 60 centimeters. The straight here lines are sticks of wood all around the perimeter of the bucket, the inside. So you make like a layer of wood. The bottom 2 layers of wood also. After the round ones are some iron or rock. After you do another layer of wood, you pile all around some wood and another layer, and you light it by the under. It's a very efficient way. If you make the calculation, you are going to see that if you pile some wood on the ground and you put your rock, your iron bits on it, it's not going to be enough performance. And here you have really a hot solution. So this was a fuel tank from a truck. You make some holes all around it and under it, and you just pile some wood and some iron ore inside. It's going to be very, very efficient way to do it. And we don't bother about the color. If everything gets red, a good red, it is enough roasted. The roasting process, it's not more about the temperature, it's more about the alchemy that is happening. We are adding 1 oxygen more in the structure. So we are getting from Fe2O3 to Fe2O4. And this is going to allow the piece of ore to be stuck to a magnet. So you can make a first research of the best bits of iron ore. So this is a big difference between industrial ore, the guy that has asked me the question before. Industrial ore, you don't have to bother about anything. And when you use traditional ore that you have dig out, sometimes you are perfectly in the good area, and sometimes you are a little bit in a mixed between the natural rock on the side and the layer of iron ore. And this mixture, sometimes it's enough rich, and sometimes you have to throw it away. So by burning the rock and try it with a magnet, you are going to see if the magnet has good attraction. It's a good piece of iron ore. If it don't stick very well on, for vaquita, put it away. Use another oven. We can talk about it, but use a bigger oven because it's going to make a lot of trash, a lot of slag. So we don't want a lot of slag in a vaquita because it's a very small furnace. We want to put something that has been roasted, caliber, maybe sometimes put together with some flour, and you do some little sugar square to put it in, so you don't have the powder that goes up the chimney with the power of the bellows. So we want something that has been really work, and 70% of Fe2O3, it's 65-70%. It's the minimum that I advise you to put in a vaquita. If you put something too dirty, you are going to have bad results.
Let's go to the next one, which is comes from Lars and is: what would be the average air input for electrical blowers in cubic meters per second?
Sorry, I did not tell you. Okay, yeah, really sorry. And this question makes me think that I didn't give you the caliber for the charcoal. Okay, charcoal has to be in caliber like a golf ball, not big and a little bit smaller. But vaquita, it's really, it's a Japanese furnace, so it's very strict. So you have really to have a good quality caliber between the ore and between the charcoal to have enough gas getting through the chimney and every layers of charcoal and iron ore to have a good nitration. So to have a good reduction process. and to not block the gas in the bottom. And for the metcubers, we know also, we know it for Vaquita, it's 240 metcubers per hour. It's very low. It's something like 4 times less than your bell blowers, electrical blowers from your forge. So be careful. And there is another parameter. You have to have 0.5 psi. So the power of the airflow, you put your hand at 10 centimeters from your mouth and you get out some air. This is the maximum air you get inside. If it's more powerful, you are going to burn the inside of the furnace. It's too strong. So 240 metcubers and the same power than when you blow on your hand, 0.5 psi. The diameter of the tuyere, I think I've written it down, but it's 30 millimeters. 30 millimeters, and you can start, so it can be a little bit like this, and you can end to 25 or 30, and you can start to 45 to 50 to have a good acceleration of the airflow inside the furnace. But if you find some pipe of clay, industrial pipe of clay that are straight, just take 30 millimeters, it will be okay.
There comes another question from Steve Rook, which is what to make with the blooms?
What to make? Everything. So first thing, you have to learn to clean this rough iron, native iron, we can say. Sometimes you are going to have carbon inside, so it is not steel. We cannot name it some steel because steel comes from the structure that is going to be organized by the forging process. So we talk about high carbon iron. It's a funny way to say it, but it's like this. And you have to learn first to the welding process. So if you want to make, maybe I can make some big categories. If you want to make a tool, it's between 4 and 6 time weld. So you get it longer, you cut it, and you bend it, and you like Damascus, okay? And welding. Between 4 and 6 time, 3-6 time for a tool, it's okay. If you want to make a weapon or a knife, you begin to 6 and you can end to 12 to 14, but 14 you are really clean. You don't have any difference. One of my master was Fernando Nava. You don't have any difference when you give the iron bar to the laboratory and they compare it to a modern steel. You don't have any difference when you have 14 times fold weldings. You don't have any more difference. So they are not capable to say which one is the industrial one. But it's a very heavy work to do. And after, when you have the bar, actually, this is the end of my job. After the bars, I give them to friends. You can make anything. So a lot of tools, a lot of knife, a lot of knife makers like to forge knives with bloom because there is a beautiful pattern, but a very not very expressive. It's not very high contrast of colors like Damascus, but you know the Japanese name it yada. So the skin of the snake. It's a very special pattern. If you show me a knife and you said is bloom, I can tell you if it's bloom or if it's old iron that has been just folded. Bloom, it's different. And after some guys in Europe still make it, like Gaël Fabre, one of my good friends that is near Fernando Nava, also in the region of Ardèche in France. He's making some weapons with it. So traditional swords, European swords. And we have also a master in southern west of France. His name is Dominique Bargiel, and he makes katana with French ore, French magnetit from the Gard. So he used French ore to do French katanas. But it's a very high profile of blacksmithing.
So there comes the next question from Mariano, which is, how big is the bellow?
You can find actually the dimension on internet. So it's the traditional Japanese one. It's a very good bellow. Mine is cost me 35 euros. So it's not very expensive to do. Okay, so this is the bellow. So you see here the broomstick that you use to action here in the center a sheet of wood. So when you push away this side, you are entering the air by this little entrance here, and this one is clapping. So there is a little sheet of wood with an articulation of lever. So it's closed. So you are pumping this side here. The air comes here inside, and you are pushing this volume of air outside this one here. And this is another chamber in front of it that supports the pipe that goes out. So the air of here goes out from here inside here and goes out. And when you're pumping the other side, you are closing here and pushing this volume outside this one, and it's going also through this pipe. So each time you are pulling or pushing, you are getting some air from outside here. So it's a double effect bellow. There is no lever. It's all sheets of wood. It's the same weight. If you do two traditional bellow from Europe, but in my opinion, this one has more pressure. It needs less strength to have the same airflow. And the other big advantage, in my opinion, it's not really the wet. It's not really a problem for him. Raining or something like this is not really a problem. With traditional European bellows with lever, you don't like to take the rain during the process because the lever, etc., etc. So I love mine because it's not expensive. It's very easy to get the spare parts redone. You just have to paint it from the outside. And last thing, it's the inside here, all around the sheet that is moving inside. You can put some skin, but from animal that smells, in the cartoon.
It's skunk.
And he has a special hair that allows a very soft movement inside. So you can put some of his skin with the air on all around to get a good movement and no air getting through one to the other chamber.
My question was because I made one, but I think was too short, was like half meter, and the travel was like too close. So I don't know. In the photos, looks like 1 meter or something.
Yeah. Of course, I can give you the dimensions.
You send me the measurements. I send them on. No problem.
Yes, okay.
No,
I can add. You can really control the flow.
It's perfect. It's welding. The welding process with a Japanese bellow. It's just the perfect bellow.
And the next question comes from Paul Voss, which is, could you tell something about the steel quality? I think this has been also a bit already answered, but maybe you could say some short words about that.
I can tell you about the steel quality, and I'm going to tell you how to make your crash test. Because it's important to know what you have produced. So first thing, the spark test. you just have your bloom, you have it, get it cold, or you have a little bit forge it in a square form, maybe cut it in half, like you want. And it's the end of the day. You don't want to make your bar directly. You let it cool down, and tomorrow morning, first thing you do is the spark test. So everyone here knows things about metal. If it's a very long and straight and not very explosive spark, it's pure iron, so it's very low carbon inside. If it's medium and it starts to make a round spark on it, you can tell it's 0.4 to 0.6. And if it's very, very, very short and very explosive, I show you the drawing in 1 minute. You can tell that you are about 0.6 to blah, 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 plus, 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 okay? Until it becomes red. So
Yes.
the first one, it's very long and very bright. So no carbon, very, very low carbon. The second one is medium and it starts to explode, to spark. So this is 0.4 to 0.6. You have produced something with carbon inside. So you have to protect your ingot. We are going to speak about this just after. And if it's really, really, really explosive, very short and explosive, here you have to protect it. You don't have the choice, you have to protect it. So burning is here, you have done your spark test, it's pure iron. No protection, you get in the forge, you get it very white, very, very white for the 3, 4, 5 first compaction process. It's pure iron. You don't have anything to burn inside. Just get it white, white, white. And forge it down and make a pyramidal shape. I like to forge like this. This is my way to do it. I like to do this, like ancients. Okay, I like this shape. Why? Because you can hold it with your tongue, and each time that you hammer it, you are getting the grains, the grains of iron that you are compacting. Every time you knock on your anvil, it's always a welding movement. It's always welding because it's always compacting together. If you make directly a bar, it's possible. It's harder to do it. You have really to be a master in welding. If you do a bar, each time you are knocking on it, you are getting the grain to the opposite. If you knock on a flat bar, you are getting it longer. So you are separating the grain. We are not on compact steel. It's not an industrial steel that you have. It's nothing. You just have bubbles of iron that sticks together with a bit of silicium that is melted. And when you are getting the bloom to the white color, anything allows it to stay together. If you hammer it too much, it's just going to explode. You are not going to have anything around you. Yeah, you're going to have 1,000 bits around you, but anything is going to be left. So the 3, 4, 5 first welding, it's a very smart, a very quick process. With a wooden hammer, it's perfect. On a wooden anvil, it's perfect. If you just have an anvil and you have an iron hammer, please be soft and really gentle with it and very fast. You want to weld the first shiny surface. You want to have something that has the same color, and you want to, this sound, you want to get all the grains together to begin to stick. The middle of the ingot in archaeology, when we found them, are often empty. You are not welding the inside. You are not. You don't have a press of 20 tons to crunch it. You just have a hammer. So you are going to do the first layer of the ingot, and it's going to solidify. So at the end of the 5/6 first welding, this is what you're going to have. An organized ingot only on the outside. So the process after, we're going to cut here and the middle, and the point is going to be on the point. So we're going to have something that it's very big to maintain. It's going to be something like this. A sort of big rectangle, and we are knocking the edges to have again, we get again on this shape. I do it 3 times, and after I do a bar, a rectangle bar, this, okay? And this after, I often use 20 or 15, not more thickness. After, in my experience, it's too thick. So I use a 20 millimeters thickness bar, and I enough long to be cut in 3 pieces. So 1, 2 knock on it. Okay, to be folded and make 2 weldings at one time. So I finish with this each time. So I did 3 welding in the pyramidal shape. And after, here I have 4, 5. And if I do it another time, I have 7. So a lot of time when I do some tool for me or knives, I stop to 7 folds to have a good quality of the structure. So at the beginning, we check the carbon inside with the grinder. After, we have done the ingot. The only thing that is going to change if there is high carbon is that you are going to need some charcoal powder and some very liquid clay. Like the Japanese, you can look some videos. The Japanese take the ingot, go around in the charcoal sticks to it with the temperature. After they go up to the bucket of clay, they put some clay on it, and again in the charcoal, again the clay, and again in the charcoal. So 2 layers of charcoal and clay, and they get another time inside the forge. They get it very hot. They take it out. They have a sort of small chisel. They get out the ingot very quickly. They get rid of the envelope of the clay that is around, and the hammerers begins to knock on it until the temperature is too low, and they start again and again. So the only difference between pure iron and steel, it's you have to protect the steel because you are going to burn a lot of carbon if you get a big piece of steel very white at the welding temperature. If it's not protected, you're going to burn a lot of carbon. So it's not a good idea. So I prefer to forge iron for the simplicity of making the ingots. And after, again, I advise you to go and read a lot of things that Lysander on his website has published on carburizing the iron after the forging process. And you have a lot of different types of carburizing. I did a lot of archaeological method with bits of cast iron between. I did the snake method, the charcoal inside clay method. I just burn the bar. There is a lot of method to get some carbon inside your bar after the forging process. So my advice, it's produce some pure iron bloom because they are. It's simpler to forge it, and after add the carbon. But if you really want to make some steel, no problem. You are going to be able with iron ore and with the ratio of charcoal inside the process of smelting, you're going to be capable to put a lot of like something like 0.8 to 1% with the vaquita, 1% carbon iron bloom. It is possible inside the vaquita. And after you're going to have to protect it like the Japanese method.
So the next one comes from Lucas, and it's great knowledge you have. What do you think is the biggest output you could have with that kind of oven? How was the production organized when the production was used for big market?
Okay. Two questions in one question. Okay. First one, the vaquita. My advice: don't get up 6 kilos of bloom. This is the maximum. I advise you, if you have a medium quality of ore, to not get up to 18 to 20 kilos of ore, because you are going to damage a lot your bricks. The oven is going to be Armageddon when you are going to open. So if you are doing it in your garden, it's okay. But if you are doing it in public, it's not very clean process because the bloom is going to be too big. So 6 kilos for something like 18, 20 kilos of ore. It's a good average. You have done your job, finish your day, get it out very hot and forge it down. I like to produce 4.5 kilo bloom with the vaquita, so I don't damage my wall. I get it out very quickly, so it's very hot. 4.5 kilo, the bloom has still a bit of charcoal around his structure, so it's very white. So I can get it under a press if I'm in a French shop that has a 20-ton press. I take the bloom and directly I put it flat, so it's all welded together perfectly. And next morning I just have to cut rectangles inside it, and I can go for the welding process. So 4.5 kilo is good with a vaquita, and 4.5 kilos or 5 kilos, something like this, you are going to produce it in between 3 and 5 hours, beginning to finish. If you are very efficient and you know your tools and you are at your 100 vaquita, I've already seen a friend, the first that has learned vaquita to me, building. So the first minute to the 5 kilos bloom in a square shape, 5 hours. So it's really a fast process, believe me. And the bricks was all clean. Again on the pile next to it, so the morning after he can just rebuild the furnace and do it again. So it's a very fast and very clean process for vaquita. Second question, for the production. So for production, I advise you this type of furnace. It's a type of furnace I know very well because I did several. So I use an iron chimney of 220 millimeters, about 1 meter high, and I build under between 500 and 700. It's 35 in the bottom and it's 220 at the top, and it's 500 from the tuyere and 200 from the bottom. So here, I used to, do you see it like this? Or maybe I put it like this, sorry. I used to work with this. So it's between 1.2 and 1.7 meters high. This depends if I reduce hematite or magnetite. Magnetite, it's 1.7 meter. It's very high. It's 30% higher. The tuyere, it's 200 millimeters from the bottom. The tuyere, it's 500 millimeters from the beginning of the iron chimney to not burn the iron chimney. And the iron chimney, it's between 700 and 1 meter high. between 500 and 700 and 500 millimeters and 1000 millimeters high. This is depends on which process you use. I have 3. This is why I put 7. I have also a 500. So I have a 500 chimney, I have a 700 chimney, and a 1 meter chimney. 500 chimney is for hematite. 700 magnetite is for limonite, goethite, and the 1 meter chimney is for magnetite. So this depends on what is the structure of the rock that you want to melt, and so how much is porous. Okay, so how many times you need to get the gas inside, and also I don't love crunching iron ore in powder. It's not my thing. I prefer smelting it. So I don't have an industrial crusher to do it. So I'm becoming a bit lazy bone. So I don't want to do a lot of crunching with my hammer. So I use a bit of rocks like nuts. And when you use your iron ore in a nut shape, you need to get up because the gas and the temperature is going to get inside in more time. You need more energy to get inside the rock, melt it down, and get the gas, reduce all the big piece of iron ore. So if you use bigger pieces, you can go to 2 meters, 3 meters high. In Burkina Faso, the Africans, I was invited this year, but actually it's a war in Burkina Faso, donc I don't go over there this year. I have the jihadist type, so I want to keep my head. But in Burkina Faso, we have a wonderful technique of Bloomering Furnace, and they build often some 4.5 meters furnaces. But it's not high furnace. It's the same technology. It's a Bloomering Furnace. They produce bloom, but they don't want to crush the rock, so they just put bits of rock like this, and they take a very long travel to the bottom to be reduced, so the temperature break it down, and the gas get inside, and they don't have any bellows. It's a natural blow inside, so it's very tall for this reason also, and they load it in one single time. So the chimney is something like 60, so it's make I don't know how many tons of materials inside. They light the fire, they get up, and after they fill all the iron ore in one time, and the process just takes 3 nights and 3 days, and to get rid of everything in the chimney, and at the end they have 12 blooms in the bottom. It's an extraordinary process. So there is a very large different types of oven. This is really my oven, this thing. So 35 centimeters in the bottom. It's a good dimension. I think it's good for all the European iron ore. You use a bit more charcoal than with the vaquita. So vaquita, you have always to prefer vaquita when you are using some new iron ores for the test. And if you have a good succeed with vaquita, use this one. It's pretty cool. You can find my videos on YouTube.
First one comes again from Lars, which is, so the vaquita doesn't have a slack pit on the bottom, as I understand.
No, this is the reason why I advise you to put something like 65 to 70% pure. So you're just going to have the bottom of the bloom a bit dirty, but you're not going to have a big volume of slag. 2 reasons. Slag begins to be a problem between 8 and 12 kilos of iron ore when you fill it inside. So you don't have any control to do until you are to 8 to 12. If you have a problem, actually, you can just knock a brick. You take a brick from under, you smash the bottom of the bloom with your bar. It's going to make it getting like this, So it's not a problem because the reduction is going to this and this for the bloom is not a problem, but you are going to break the one corner and the slag is going to get down. So it's not a problem. But I advise you to use good ore in a vaquita. If you know that your ore is really disgusting, use this. It's going to be perfectly the same way to do it. 5 minutes between the load, control the temperature, control how it smells. Same thing, but it's less efficient about energy saving. So you're going to spend more money to try an iron ore that you know it is dirty. Everything is around money today. Yeah? Even if we are here for culture and saving technologies, it costs a lot of money. I produce my own charcoal, so it's not a lot of problem for me. So this is another thing that you can ask for me for presentation for another time. But charcoal is quite expensive, so you like to be always efficient. Wood also it's expensive, not for us but for the planet. It's a thing that grows slowly, and we don't like to pee on the nature. So we does a lot of damage to nature. So this is the reason why I also present you and explain you to do the burning process like this in a tank that's use less wood. So less wood, less charcoal, less time. You can reuse your brick. This is why I choose to present you the vaquita, because of the efficiency of this technology. But it's sure that if your iron ore is not good, you are going to have problems. It's going to be all about rusting, and after you can check every bit, or you can check the powder with your magnet, and you can just keep what is really sticking to the magnet. This is one of the things you can do for sure. Don't throw in your vaquita piece of iron ore that don't stick to a magnet. Don't throw them inside. It's not going to do anything good.
Well, the next question goes a bit into the same directions, which is, can you use bad charcoal in this type of vaquita? I mean, when it's not from hard wood.
Here we have one galaxy. It's a smelting, and you have another galaxy that is gorgeous about charcoal. You can talk. We can talk a few hours about charcoal. Charcoal, hardwood. It's not the best. I explain why. Industrial charcoal is very bad. It's a lot of ash inside. It's very heavy, a very high content of silicium because it's partly unburned, or it has been burned too fast with gas. It's very stupid technology they use. So I advise you to use charcoal for the restaurants. When you have restaurant quality for grill, I recommend you to use this and a mixed, if you can read behind it, and you have a mixed between helm, elm, pin. If you have a mix of the three, it's not a bad thing. So pin, it's a very light charcoal. Actually, it's very good for the vaquita because it takes some space and it's very light, so it's going to fall constantly. It's not going to be really hard to get rid of because the temperature in a vaquita is very low. So you can use pin, very light charcoal in a vaquita. It's very good. But in a bigger one, like this one that I advise you, if you have a different holes, but don't go in a vaquita, this one, you can use a mix between the two. Oak, I only forge with oak. I don't like to put some oak inside the furnace. Why? It's very heavy, so it don't take some space inside, so it cannot support the rock, the iron ore layer. You have to get a certain space between them, and if you have a very light charcoal, you're going to have a layer thick like this. And if you have a very heavy charcoal like oak, you're going to have a layer like this. So this is not good. So I don't like oak for this first reason. It's very heavy. I don't like oak because it takes a long time to burn. So if you threw a piece like this, like a coin, when it's going to get to the bottom, it's going to be like a button. I like to have nothing in the bottom. I don't want any more the charcoal. So when it gets through the tree, it has to disappear nearly 10 centimeters down the tree. I don't want anything. I just want my bloom. I don't want to have charcoal. I don't want to have ash. I don't want too much slag. I just want a full space of bloom. This is what I want. So a heavy charcoal is going to be always mixed with your bloom in the bottom, so it's going to get some hole in the bloom, etc. So it's not a good charcoal for vaquita, and it's not a good charcoal for that type also of oven. But in the opposite, in the history, we found actually a lot of oak, charcoal oak inside the archaeological site. Why? Because they often used furnaces that have 60 to 1 meter inside. So these big furnaces, to have a lot of energy, they used some oak. Because the capacity of the oak to burn slow and support a very large area, so support the structure of the furnace, it's very good. So they use the opposite thing that we don't want to use today in small oven, because you don't want to get you don't want to buy charcoal for a 60 or 70 centimeters furnace inside. You don't want to do it, I assure you, because if you want to run it, it's maybe something like 1,000 euros you're going to spend to run a furnace of this type. So you don't want to make an experiment with 1,000 euros. So ancients used a lot of oak for this reason, and we don't want to use oak for our reason, because it's not good for small oven, because it's too trashy and it's too heavy.
When you cut and weld the blooms, what fuel do you recommend?
Gas. You are going to have the limit of temperature. You are going to damage your gas forge. You can do it. It's going to be okay for the temperature, but you are going to damage a lot your tools. So it's not very good to do it if you don't care about your gas forge, because it's a home build. Okay, you can do it. But be careful, the temperature that requires the bloom, it's something like 1,600 for pure iron on the 2 first heats. It's very white color, so you are melting everything in your forge. So you're really going to make some bad damage to your gas forge. The coke forge, so the coal forge. The coal forge, it's okay, but you have to be really focus on your fuel. You have to bring it very slow to the center. You have to get rid of all the yellow gases, sulfur and phosphor that is inside the coal. You have to manage your fire to get it closer. So you have always to put some new coal around it to get it slowly to the center, to not burn some new coal near your bloom, because you have a chance, it's not 100%, but you have a chance to contaminate your good iron with these elements, because like I said it to you a few minutes ago, the structure, it's very porous at the beginning. It's only grains with silicium sticking together, and it's not really a structure. You are hitting it, it's going to lose a lot of volume very quickly. You're going to see this. You're going to lose a lot of scales, of everything, because a lot of silicium is going to get out of the structure. So this is the opportunity for other elements to get inside. So it's okay to forge with coal. For example, a lot of American guys forge with coal, and they don't have any problems, but you have to be careful. My advice, if you really want to be really sure that you are making a good fire with your coal, is to burn it before. So you do a fire just outside your workshop. It's going to make less smoke inside your workshop. You pre-burn a small capacity of forge. You just take a shovel, and when you need some coal, you get this one that has already burned one time. So there is no more gas in it. And charcoal again, I know it's the more expensive fuel, but it's going to be the better, the cleaner, if you want to have a very clean iron at the end. Is not going to get you some contamination. It's the more precise fire that you can get. It requires the more experience also, but it's going to be a very precise heat. And also you have the capacity to put some carbon inside your bloom during the process, and you cannot do it with the forge gas that is neutral. Okay, there is no oxygen or no carbon inside the flame. And with coal, don't get in this reduction zone, because the most gases, nasty gases, are in this reduction zone where the oxygen is getting lower. So the temperature it's less higher. So the elements still here. If you forge with coal, always get inside the white color. You have a less chance to get some nasty elements inside the white zone.
I think, Adrien, you forgot the cokes.
I said the coal. Cokes. Indeed.
Cokes.
Yeah, but cokes, no, you cannot forge with cokes. Okay, if you have an electrical bellow with the hell on earth of the quantity of oxygen, you can actually forge with coal, with coke. But it's very, very hard to maintain it in a high temperature. It's a hard fuel to get for bloom. It's a hard fuel. Maybe for bars, it can be good because you can close a bit the structure of a fire. But we don't want to do it with the bloom. We just want to have burn coal, a thin layer, and just some maybe 2 centimeters of burn coal up the ingot. But we want to see. We always have to see when I weld with charcoal. I just have something like 2 or 3 charcoal up to it, so I really see the color, and I really see the ingot that is shining, the slag that is dripping, and I know the time to get outside and put a few hammer on it and get it in and out and in. When I'm doing really the last welding process, the anvil, it's maybe at 10 centimeters of the fire. It's really near. You just get out and to not lose the temperature, and to let the minimum time the iron inside the fire. Because if you burn, if really you damage the bar at this step, it's more damageable than in modern steel, but you can just clean it and get it another time forge. It's harder. You have to fold it again if you do it with Bloomering Furnace, Bloom steel. If you do it with Bloomering steel, it's going to really damage the structure that you have built. So you have to fold it again. So you have really to be on your work when you are doing the last welding.